In this session, we have created a function here called scaling in which we will pass the test images and the test path. And then we have created an empty list called images. And then I have passed test images into image path. And now we are opening these images by resizing them with size 50 by 50. And we are converting them into NumPy array using np.array and dividing by them 255 in order to normalize them. And in the end, this function returns these images. So here I have imported a new library. As you can see, from pill I have imported images, and this image function is used to open these images. So we have created a function. Now we will call this function using our test data, and we will scale test images and store in test images variable. As you can see that our test images are being converted and are being normalized and are converted into NumPy array. Next, we will see the prediction. We will use the model to predict classes on the test. So next, we will store the classes and name the labels into a variable name called all underscore labels. So we can use this information for prediction. I have taken this from Kaggle and stored them into a variable name called all underscore labels. As you can see here, we are showing all the levels. So the labels are stored. So let's visualize this test image. So this is a test image we have taken, and now we will make the predictions on this test image. So let's print this and see what is the original image. So if we print the original label, the original label is a speed limit 30 km/h. So you can see that the label in the image is for 30 km/h. And let's see the predictive label also. So here the predicted label is also 30 km/h, which is exactly same as that of the original data. For the original label, we have passed the y test, and for the predicted value, we have passed y predicted data. So we can see that the prediction is accurate here. So with this, we came to an end of this project. And to conclude, we can say that we have started with downloading the data set, then we have processed it, and in pre-processing, we see how we have converted the data into NumPy array and normalized it by dividing with 255. And after that, we have created the model. We applied different layers like convolution 2D, mathspool 2D, and other layers. And you can change those layers according to your requirement. After that, we make out some predictions on this model, and we found that our predictions are accurate. So during pre-processing, we found out that this data has 43 classes, and the model used is accurate up to 95% in just 50 epochs. So we have trained this model again and again on different parameters to optimize it. You just need to hyperparameter tuning this model and reach higher accuracy. Also, we saw that this model is showing some overfitting. So in order to reduce the overfitting, you can go for dropouts and regularization. You can check out the Keras documentation for dropouts and regularization to apply that. The scope of this project is that this model can be used in self-driving cars, which will enable them to automatically recognize the traffic signs. Similarly, the driver alert system, which alerts the driver inside the car and will help them and protect them by understanding the traffic signs. So this is all about the project traffic sign classification. Thank you. Till then, happy learning.